Good morning, doctor. Today we are going to present our project, which is the Smart Fire Detection and Emergency Response System. I am El Poijet.
I'm Pang Xiaoxun. I'm Do Yihao.
In this new era, although the technology are advanced and modern, there still happen the fire accident around the world. The main reason causes this accident happen is the cost installing the fire alarm system are very high, and the people think that it's not important enough to make this alarm system. Thus, we create this logic circuit is to solve these issues. And for our block diagram, we got 4 inputs and 3 outputs. The 4 input is smoke detector, heat detector, flame detector, and carbon monoxide detector. And the 3 output is steady state, stand for X, warning state for Y, and emergency state for Z. The relationship between inputs and outputs is only when all the inputs which the detector shows 0, then only the X will output 1. And for the Z, when flame and carbon dioxide or heat detector input high, it will output Z. And for the rest, that it will output Y. Okay, this is our truth table, which is related to our relationship, and the K-map, which is obtained from the truth table, and the below one x, y, z is the simplest expression obtained from the K-map. That's all for me. Now I pass to my friend Pang.
I'm Pang. Right now we're going to talk about how do we create the block diagram in Quartus. First we select the file, create name, and then we open a file, new file, block diagram. Here's a feature we can use. We can select logic gate that we want to use in here, and also input output in here. We've done this our basic gates. Then let's simulate it. We save a file, wait for here to process. After processing, we create a new university program. I will click here, not finder, list, then copy here, okay, okay, and then we're gonna set a period. Gonna stimulate it, simulate setting, delete the not, delete the code here, save, and then run stimulation. Yes. Save file. This is our result and it's great cool. Other than that, we also create a non-get over here and let's see the result. Here's our non-get result and this is fine and correct.
So, thank you, Pang. I will proceed with how we construct our logic circuit using the NAND configuration from the basic gates. The first step is I will add bubbles to the basic gates and pushing them to the left or right. Next, I will use the relation between the NAND gate and its De Morgan's equivalent. The third step is I will implement all the NOT gates in our circuit with NAND gates. So, first of all, I will add all the bubbles here. And for the first bubbles, it will be moved to the right, 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 and this one to the left. So for these two OR gates, they are filled with bubbles here, and they can be converted to its De Morgan's equivalent, which is a NAND gate. And just now we can observe that there is here one bubble here and one bubble here. These two bubbles can be is actually a NOT gate, and these two NOT gates with these four NOR gates can actually converted to a NAND gates. And this is our final logic circuit with NAND configuration. So although the number of NAND gates used in NAND configuration is more than the number of basic gates used in logic circuit with basic gates, but in real life or in industrial factory, most of us will actually implement the NAND configuration due to a few of the characteristic of NAND gates below. The first one is NAND gate is a universal gate. It can be used to design any logic circuit. And the second one is it has low cost production compared to other basic gates. For the last one, it is very efficient in terms of circuit area and power consumption. So in conclusion, the public must be encouraged to install a fire alarm system in their homes or workplace to reduce the chances of happening fire accidents. And that's all from us. Thank you.